Hey y'all, welcome to the last lecture in chapter 6. So we're going to talk about the terms oxidation and reduction and how it relates to metabolism. So oxidation in a nutshell, and this is going to turn red. I don't like red. I don't hate red, don't get me wrong. I like, oh, whoa, what just, okay. Oh my God. All right, you know what? I'm just going to use red because I don't know what else to do. The term oxidation is the loss of electrons. That's what it means. And the term reduction is the gain of electrons. So remember in your chapter 2 where we were talking about ionic bonding, and you had one atom here that had, a proton and a proton and a proton, and then it had, at the same time, it had some neutrons, so a little neutron and a neutron and a neutron, right? And then in the outer portion, I'm just going to use purple, it had electrons, right? And so the first orbital, it had 2 electrons, and then in the second orbital, it had 1 electron. All atoms want to have a full outer orbital, so if it gets rid of this electron here, it'll have a full outer orbital because the first orbital can only hold 2. So if it comes in contact with another atom that has, and I'm just going to go back so I have the same coloration, that has, say, 1 proton and purple, yep, and an outer orbital that has 1 electron. If this atom gives an electron to this atom now will have another electron here and have an outer orbital, and this outer orbital is going to be erased, right? And so this atom becomes positively charged, this atom becomes negatively charged, they become ions, and they are now going to be stuck together, right? So oxidation, loss of an electron. This atom here was oxidized. And this atom here gained an electron, so it was reduced. It now has a negative charge because there's 1 proton and 2 electrons. This one has a positive charge because there's 3 protons and only 2 electrons. Now, oxidation and reduction reactions are coupled reactions, and this is because when something is oxidized, something else has to be reduced. So we often call them just redox reactions. And so this is what oxidation and reduction look like. Here we have some atom or molecule A that is called a reducing agent. It's a reducing agent because it's going to lose its electrons. It's going to give its electrons to something else. And here is atom B or molecule B. B is called an oxidizing reagent or agent. And the reason it's called an oxidizing agent is because it's going to oxidize the other molecule. It's going to take those electrons. And so A becomes oxidized, B becomes reduced. So this is why it's also known as a redox reaction. So you learned that in chemistry, but in biology, when something is oxidized, it's also losing hydrogen ions. So loss of electrons and hydrogen ions is oxidation. Loss of electrons and hydrogen ions, okay? And then reduction is the gain of those hydrogen ions and electrons. So reduction is gain of electrons and hydrogen ions, okay? And so how does this relate to metabolic reactions? So in chapter 7, we're going to talk about a metabolic reaction called cellular respiration. And in chapter 8, we're going to talk about a metabolic reaction called photosynthesis. So these reactions are really the opposite of each other. So in cell respiration, glucose is oxidized completely. Oxygen then is reduced to water. But in photosynthesis, water is oxidized to oxygen, and carbon dioxide is reduced to glucose. So down here, this is the metabolic equation for cell respiration. This is glucose. This is oxygen. This is carbon dioxide, water, and energy. So in this reaction, glucose is oxidized to carbon dioxide and oxygen is reduced to water. In photosynthesis, water is oxidized. Oh, I'm going too far, aren't I? Water is oxidized to oxygen, and carbon dioxide is reduced to glucose. So they're the opposite reactions, okay? So where does photosynthesis occur? It occurs in the chloroplasts of different photosynthetic organisms like plants, algae, cyanobacteria. And what they do is they take in energy of the sun and they convert it to ATP, and they use that energy then to reduce carbon dioxide to a carbohydrate like glucose. So in photosynthesis, oxygen is a byproduct and is released. And so if you're looking at photosynthesis, the equation for photosynthesis would be H2O, plus CO2 plus energy, and this would be from the sun, produces C6H12O6 plus 6O2. And I guess I should put this over here. 6CO2 and 6H2O. And so this is what the reaction looks like. And this is, again, glucose, oxygen, carbon dioxide, and water, okay? So in cell respiration, we're looking at the mitochondria. The mitochondria is the energy producer for our cells. And so what the mitochondria does is it helps in the oxidation of glucose. So oxygen is taken in this process, and carbon dioxide and water are produced. And you saw the reaction in the previous slide for photosynthesis, and in the slide before that for cell respiration. So I'm not going to write that out again. So when we look at the amount of energy we produce in cell respiration, we can produce a total of 686 kilocalories of energy. And that energy then is used to drive the production of ATP. And so the cells use that ATP then to oxidize other glucose molecules, allowing more energy to be produced and more metabolic reactions to occur. So carbohydrate production occurs in the chloroplasts of plants, and then we eat those plants to gain energy. And then cell respiration occurs in mitochondria. Both plants and animals have mitochondria for ATP production. And I think that is the end of the slideshow. So we'll get more in detail on both cell respiration and photosynthesis when we get into chapters 7 and 8, respectively. So you guys have a great evening or day, whatever time it is, and I'll get these uploaded soon. Bye.